Hi and welcome to my video on how to go from the graph of a linear function to the function itself. Enjoy! So the first thing we need to consider is how to find the gradient. So you've learnt this a couple of ways in your time in year 7, 8 and 9, and one of them will be that the gradient is equal to the rise over the run. This is probably the first method that you learnt, and it's pretty easy if you've got a graph, and so we'll talk about that as well. And the second one that you've probably learned is that m equals y2 minus y1 over x2 minus x1. And again, it's a pretty easy way once you understand it, although it looks very algebraic right now. I understand that, I see that. So m equals rise over run. So the first thing we have to do is determine what we mean by rise over run, because it's important we get our negatives and positives right here. So there's a couple of ways you can think about this. The first thing is build a triangle. It doesn't matter whether it's this way up or you just build this triangle here, but this one's easier for me to see on the video. So this triangle represents the change that's happening as I move from this data point here to this data point. These are my two data points I know stuff about. So as I go along here and down there, I can see that I have a run of 4 and a rise of 2. So I've got a triangle that has 2 and 4. So that means my slope, in this case, m, is rise, which is 2 over 4. Now there's a couple of things you can do. Firstly, I'm going 4 in a positive direction, but 2 in a negative direction. So it's actually down 2, which means my gradient's negative. So if you think about it as in positive negative for your rise and positive negative for your run, then that can help you develop the correct gradient, negative or positive. The other option is just do the 2 over 4 and then look at the line and say, is that negative or is it positive? And once you've determined that, you can just throw the negative on there as you need to. Anyway, we get a negative 1/2 out of this, which is great. The second one revolves around y2 minus y1 over x2 minus x1, and it comes from the idea that if you have two data points, let's say x1, y1 and x2, y2, then you can find the change in run by doing, this is x2 minus x1, because this is x2 and this is x1. That will give you that gap, because it's a difference. And you can also find the change in rise as y2, or in this case that's y1, but it doesn't really matter, minus y2, and that will actually give you a negative value, which is great because we're expecting a negative gradient. So we'll talk about that in a second. That's where it comes from. I'm going to use these two data points, and I'll do this working in green because that's where we started. So we've got this data point here which is 0, 2, and this data point here which is 4, 0. Now it's important that you are consistent with your use of 2 and 1 here. It doesn't actually matter which one I choose as point 1 and point 2, but it does matter that once I've chosen it, that stays point 1 for my y's and x's. So y2 minus y1 is going to be 0 minus 2, because I'm using this as my 2 and this is my 1. And then x2 minus x1 is 4 minus 0. And that gives me negative 2 over 4, which gives me negative 1/2 again. So I'm happy I got the same answer. Either way, that's how we find our gradient. The other thing we need to do, of course, is find our y-intercept. Now, in this case, it's pretty easy. So you might get lucky and find that the y-intercept is given to you. And so this function, of course, is now y equals mx plus c, which is negative 1/2 x plus 2, because my y-intercept is 2. That's where it passes through the y-axis. That gives me my function. I've calculated my gradient, and my y-intercept was visible. What I do now is show you an example, which is actually a really standard way of doing this type of question, where two data points are known and the y-intercept is not obvious, and how we go through that process. Okay, so here's an example where I've got my two data points. They're known. I don't have a graph. I don't know my y-intercept. I don't know my gradient. I want to know the function. Now I'll give you fair warning. I've chosen these two data points so that the numbers that result are not actually that nice. They're not bad, but they're not that nice. So I just want you to see that this process will get you the right answer irrespective. If you've got a calculator, there's nothing hard about it. So just quickly though, and you don't have to do this, I could choose to just throw up a little graph here. And I've got 3, 7 is about there. Of course, you'd have a ruler, etc. And negative 2, 4 is about here. Okay, and it's not a bad idea to just somehow get an idea of what my function is going to look like. So if I have a look at this, I can see my y-intercept is going to be somewhere between 4 and 7. I've already got an estimation of it. My gradient doesn't look like it's quite 1. It's probably going to be somewhere near half. I've got a bit of an idea, but I'm not going to use that. What I'm going to do is I'm going to use the methods from earlier in this video to start by calculating my gradient. So we're talking about y equals mx plus c, and I'm going to say that m is equal to y2 minus y1 over x2 minus x1, and I'm going to call this one 0.1 and this one 0.2. So I get m is equal to 7, the y value from my 0.2, minus 4, over 3 minus negative 2. I'm being very careful with that negative 2 because I need to make sure I represent the fact that the number is negative. So x1 is negative, so it's minus a negative number. And this, of course, comes out as 3 minus a negative number becomes 3 plus that number, so 3/5, or 0.6. So my function is now y equals 3/5. I prefer fractions myself, but you could use 0.6. Just be careful. If you decide to use 0.6 or convert the fraction to a decimal, but you need to round, it creates inaccuracy. So as soon as you start rounding, you've created inaccuracy, and you want to hold that back for as long as possible. So if you can use the fraction, that's probably the best way to go. But here we go. Now I've got this function, and I've got a gradient about what I expected. I'm expecting a y-intercept between 4 and 7, probably somewhere right in the middle, like 5.5. But let's see how we go. 3/5 of my gradient, there's my function. Now I need to find c. So if I knew x and y, I could find c. And here's the interesting thing. I do know 2 instances of x and y. It's this point and this point. So I'm going to use one of those 2 points to calculate my c value. And I get to make a choice now. Usually I try and pick the smallest numbers. If there's a 0 in there, I'll pick that. But you know what, I really hate dealing with negatives. So I'm going to avoid that negative, and I'm going to go to this point here. I'm going to put it in there, and I'm going to calculate my c value. So I'm going to say at x equals 3, y equals 7. That comes directly from that data point. So let's use it. I get 7 instead of y is equal to 3/5 times 3 instead of x. I'm just substituting plus c. And so therefore, 7 equals 9/5 plus c, and c is equal to 7 minus 9/5. Now I'll put that in a calculator. You have a calculator for all your exams. 9/5 is 1.8, so I get c is equal to 5.2, and that gives me y equals 3/5 x plus 5.2, which I'm going to write down as 26/5, but we could also have y equals 0.6x plus 5.2. Now, the only thing I would say is if you're going to use fractions, use fractions. If you're going to use decimals, use decimals. Try not to mix them up. Let's be consistent in which one we use. So there we have it. You can get the function from data points if you follow this process. It always works. Even if you're given a graph, just find 2 points and follow this process. It's probably the most important thing from this topic for you to learn, how to go through this process to get your function. Well, that was definitely fun, wasn't it? All the best.